Good day, and welcome to the demonstration of Report Plus 8, the Advanced Management module for Photometric and Spectrometric reports, using our file OXL 8.0. Okay, in order to prepare your report, you need first to create the OXL file, which is the base file where you can input all the information needed then to print the report. In order to do that, we select a photometric file coming from the laboratory. This is a GF file, which is a file produced by our goniophotometers. You can simply drag and drop the file into PhotoView. At this stage, you have to check if the photometry was done in the proper way. Usually we select the values over here, and we check if the difference in between them, being at gamma 0, so they have to be the same, exactly the same value, we check if the difference is below 1%. If it is below 1%, then we can normalize the matrix, selecting Edit, Normalize. So with this feature, we come to, as you can see here, the same value. This is the first step. The second step is to fix the matrix at 100%. So this is a matrix for LED luminaire, and it must be at 100%. But sometimes when you do the normalization, then you may find here that it is not exactly 100% because always some approximations are included. And so pressing here 100%, you fix exactly the matrix at 100%. But then, as we can see here, there is the need to turn the asymmetric part of the photometry because, as you can see here, it is on the left, which corresponds to 180. But usually the asymmetric part of a photometry should be at the right. So it should be at gamma 0. How to do that? We simply select the Z rotation and 180 degrees. And the photometry will be turned 180 degrees. So we confirm, and then the photometry is ready. But in order to print the report, this is the first step. We need to include other information. So we come to the general data about the luminaire photometry. Over here, we have to define the code because whenever we import a GF file, we only have the code from the laboratory, so the code of the measurement. So in here, we can input exactly the code 001A, for example, and then we have to define the dimension. So we have to select whether the luminaire is a rectangular. So the bounding box of the luminaire is a rectangular one or a circular one. We select rectangular. We say 650, 450, and height of 150, and confirm. And then the luminous area. Again, rectangular, 450, 350, and we'll leave the height at 0. It means that the emission is on a surface. So let's consider that in this case, there is the glass, which is a plain glass. Okay. Once we confirm, the program has to confirm if it has to calculate the glare area at 75 degrees. Then we have to input, for example, the instrument list. PhotoView allows you to select a table that you can get from the desktop. We select Report Plus, we get into tables and instrument tables. And from here, we select this table, the complete list of the instruments. So we have a laboratory over here, and this is roughly the list of instruments that we use over here. In this list, we can define the code of the instrument, the internal code, the type of the instrument, the manufacturer, and the model, and the parameter which you want to consider, the quantity. So in this case, you can see here the unit, the calibration expiration date, and the correction factor. So it means that in here, it is also possible to include the factors that you get back whenever you send an instrument to calibrate, and it was not possible to adjust the reading of the instrument. So you have to apply the factor, and if you confirm, the program will ask you if you want to apply the correction factors. Okay. In here, if you want, you can input added information that will be used by the program whenever you want to save the information into an IS-XML TM33, IS-TM33 file, or into the UNI, the Italian standard UNI 11733. Okay, but then, coming from what the standards, so for example, LM79 for the IS and EN 13032-4 for Europe, you have to include other information because, for example, the uncertainties are mandatory. So whenever you supply a photometry, our standards are saying that you have to supply together the information related to the uncertainties. So in this case, we open this window and we load the table, and we go back, we select uncertainties, and we select the Oxitec ones. So as you can see here, the list of uncertainties will be displayed. We confirm, but also the standards. It is necessary to know following which standard the measurement was done. So again, we select, we load, we get into the standards folder, and we select this one. These are information that must be printed at the report, because whenever you look to the report, you have to know following which standard the measurement was performed. But it's not all, because, for example, a report is also coming with images describing the product, describing some particulars, and describing also the references, and sometimes also with some images about the instruments. How can we do that? We select Image Manager, and through here, we have a set of boxes we can fulfill with the images. So we select the first image we want to put at the first position, then we select the second, and this way of managing not only a single image, but a set of 4 images allows you also to include the other characteristics of the luminaire. So in this case, for example, it is coming, this image is carrying all the information about the driver or about the luminaire. And sometimes at our laboratory, at least, we had here also an image about the lenses. So you can at any time go back, select the file. We are going to save the information. You load the file, and then you will have in a single position, in a single file, you will have all the information you may need to understand if something was not good, to understand which were the lenses that you use at your measurement. But then over here at the second line, we have the reference image 1 and 2. So for example, we select this one because it is essential to visualize how the luminaire was linked to the photometric system, in this case, the C-gamma system. And we also had this other image, which is related to the point. This is the laser about the horizontal axis, which, as you can see here, it is perfectly centered at the luminaire. So it means that the luminaire will turn around this point. Again, there are other images about the instruments. So for example, we select instrument images, and let's say that in this case, the measurement was performed using a lux meter, and we place it here, and this multimeter, and we place it here. Okay, we can, at this stage, we can confirm. As you can see, I'd like to add also, it is also possible to add the signatures of the responsible of the laboratory and of the technician about the laboratory, which can be included here. Then we saw images, we saw standards, we saw uncertainties, instruments. There are other data that should be added, and these data are about the company, are about the notes, are about the limits coming with the standards. You have to, in this case, select options and company info. Over here, as you can see, it is mentioned the company name, company address, phone, website. The laboratory manager signature will be the one of Stefano Borsani, myself. The laboratory technician signature, the repro version, and in this case, having the program into English, it will be possible to print into English, but it is also possible to select another language. So you can work, you can use the program into English, and you can print in one of the 25 available languages. So for example, Italian, English, etc. And we go back to the English. And over here, there is the title of the report, and note 1, 2, and 3. And also 4, where, for example, in this case, the data in this report correspond to those collected in the manner mentioned above, etc. Then over here, we have the electrical test parameters. So the source, the voltage coming from the standard, harmonic distortion, again, coming from the standard, the frequency. And this is about the electrical test parameters. And this is about the environmental conditions. So we mention here the temperature, we mention humidity, and we mention the air movement. So that's it. All the information were included at PhotoView. So we are almost ready to start with the printout of our report. But first of all, we have to, and we want to save the file. So our program allows you to save into different file formats. We can save into ULUMDAT, but if you save into ULUMDAT, all the added information besides the photometry will be lost. And also with the EIS and M63, again, also with the CIPSI. So almost any file would not be, with those files won't be possible to print and to save images, for example, to save the information about the standards, to save the information about the uncertainties. The only file that can allow you to save all those information is the Excel file. The Excel file is a file that we started to develop back on 2007, and we were pushed to develop this file because we had in mind to have a much stronger file through which we could manage all the information at our laboratory. And so that's why we came to the OXL file. The Excel file allows you to save all those information. And so whenever we select it, we save, all the information will be automatically saved. But we forgot to add another set of important information, such as the spectrum. So PhotoView is capable of managing also a goniospectrometry or a spectrometry. The difference is with a goniospectrometry, you save a spectrum in correspondence of any point of the matrix. So gamma 0, C0, C0, gamma 20, etc. So you have a huge set of information because it is no more, let's say, a matrix of 200 intensities. It is a matrix of 200 points by 400 if we stay in the visible range. So in between 380 up to 780. So in this case, in place of having only 200 points, 200 intensities, we have 200 by 400 values. If you have a spectroradiometers with a step of 1 nanometer. In this case, so you come to a total of 80,000 values that you have to manage. So it's a huge set of information that you have to manage. On the other hand, you can also use the program in order to import a single spectrum, so the spectrum of a point. The program allows you to do both. Let's import a file coming from a goniospectrometry performed at our laboratory. This file is a raw file, extension raw file, and we simply drag and drop. The program at this stage is proposing us to select which is the standard that we want to apply. Let's say that we want to apply this one. We confirm. The program will visualize all the different spectrums you can select from here. And once you have finished to analyze them, you can confirm, and the spectrum will be included. Again, the Excel file allows you to save also the spectrum at the same file. So the Excel 8.0 allows you to save images, to save spectrum and spectra, as you can see here. To save all the information related to the measurement, even the electrical parameters. So, for example, we are living in the LED world, and we should use for example, all the information about even the current. But with a ULM.file, file, it is not possible. So now people working in lighting, they have using ULM.files. Files. Whenever a manufacturer has to transfer the information to the market and also about the current, they have to transfer the information through the description of the file. It is not possible to manage it at the file itself because it was not thought when it was introduced, when the LDT file was introduced back on 1990. So let's come now to how we can manage the printing of the report. So we select this feature, which is File Customize, where we can define which are the pages that we want to print. In here on the left, we have the full list of available printouts, and simply doing the drag and drop, we select from one side to the other. This is the list of the printouts about our report. So it is also possible to save the printout. So for example, we do not use the same printouts and graphics for different luminaries. So a road luminary has a set of printouts of its own, like a floodlight, like an interior luminary. They have different approaches because they are about different areas. And so you may save different printouts templates so that you don't have to go to define at any time you need to print. Anytime you have to define the new set of printouts you want to use. So once we have finished, then it is possible to confirm. We go back to File, Preview Custom Print, and that's it. Your test report is ready. We can analyze it. So we have the cover, we have the contents page, we have the measurement data, test data, we have the instrument data, and from here onward, we have the printouts about the measurement. So, for on this page, this is a summary page about the measurement with the polar diagram and the image of the luminary. And next, we selected to have the Azulux curves. In this case, we said to have the intensity, luminous intensity matrix. And at the end, all the part related to the spectrum analysis, including the M30. So in this way, it is possible to print a single spectrum, a single report. But PhotoView allows you also to print more than one report. So whenever you have a set of, let's say, 10 different Excel files, you can select Batcher, Dir to Dir, and at this stage, you have to select the options Print Custom. It means that you want to print exactly the same list that we have been configuring so far. So in this case, you confirm, and whenever you run batch, the program will start to print all the different reports without losing time. So that's it.
Thanks.